The next segment has been given to us by the Institute of Physics, and we thank Margaret Cross for putting together this video in her garden a few weeks ago, and also involving some of her apprentice helpers in explaining floating and sinking.
Welcome to Science in the Park. My name is Margaret Cross from the Institute of Physics. Last week I had two little helpers to do some floating and sinking experiments. Girls, when you were younger and learning to swim, why did you have armbands?
So then we would float and not sink to the bottom of the pool and drown. What I'm going to show you today is an experiment called dancing raisins. So all you need is some raisins or some tana and some lemonade. So you need to get fill your see-through cup of glass with lemonade and get 5 raisins.
So what are these bubbles in the lemonade?
Carbon dioxide. So what we're going to do is we're going to drop the raisins in one by one. We want you to watch what happens to them.
So what are they doing, Ivy?
They're dancing,
Well,
going up and down.
so when they sink to the bottom, they get covered in carbon dioxide bubbles, which means they can float, and then they float to the top, but then they lose those carbon dioxide bubbles, and then they sink to the bottom, and they go up and down, up and down. When the raisins are covered in carbon dioxide bubbles and floating at the top of the lemonade, they are less dense than the lemonade below. But when they're sunk at the bottom of the lemonade, they're more dense than the lemonade above.
So I've just been having a wonderful time playing around with a way to show you how you can enjoy making liquids float on liquids, because the more dense liquids will sink and the less dense liquids will float. Right, so here we are in the garden where you can make as much mess as you want, really. I'm going to start off here with honey. I've poured it into the jar already, and I'm going to add some washing up liquid to it. I'm going to use my glue. So you can see now that the fairy liquid is floating on top of the honey, and that's because the fairy liquid is less dense than the honey. Next one I'm going to do is with 3 different colours of fairy liquid and with cold water. So first of all I'm going to put the 3 different colours on the base. The second one, and here's the third one. If you've got red fairy liquid, that's even better. So you should be able to see the 3 different colours. Now, to do this carefully and avoid the mixing, I'm going to pour the water over the back of a spoon. That's why it's good to do it outside. And if you look sideways on against the white background, you should be able to see I can certainly see the blue and the green washing up liquid with the water sitting on top. I think this time I'm going to try with some golden syrup. It's quite old. It's going to pour into the jar. Next I shall pour some milk. But I'm going to now try on top of the milk some fairy liquid. Well, I think that's fairly conclusive that honey is definitely the most dense. The washing up liquid is the second most dense, and the milk floats on the top. But I'm going to add one more layer. Oil. I think I will put it over. I'll put it in slowly, but oil doesn't actually mix. Leave it to settle, and you will see that the oil, which although oil is thick, it's actually less dense than the other liquids. Right, for the last one, I'm going to use green fairy liquid. Red dyed water on top of it. We'll see how that goes. The next thing I'm going to do is to pour oil on. Okay, so even there are still some bubbles in the oil, I'm going to put some milk on. Is the milk going to sink? Let's see. I think the milk has gone down into the water layer and mixed with the water. I like that one. I think that's really good. That's 4 successes out of 5. You try. Let's see that. So now you know about oil floating on water, I'd like you to watch my 2 young friends showing you how to make a lava lamp. Can you tell me what's in that jam jar first, please?
So first at the bottom we have a quarter of the jam jar or cup is filled with water mixed with whatever food colouring you want, and then the rest of it is filled with some sort of oil, and here we have fizzy tablets. So my sister's already broken hers into bits, and what we're going to do is we're going to drop them in one by one and just watch the bubbles start to rise. It's better to drop them. I'm going to try dropping a whole one in because that will make it much faster.
No, it won't. It will make it much slower.
Will it? Or will it not?
So what's
So
happening?
you have to. So these bubbles are full of carbon dioxide.
Okay.
And when they rise to the top, they lose the carbon dioxide they've gone into the sink, and then they rise and fall, and it's basically like a lava lamp.
So they're bubbles with water around them rising up through the oil.
Because they're full of carbon dioxide.
Mine is already in action.
So is mine.
So
We
watch
had
this
to
for
look at
ages.
If you look there, you should be able to see.
See, here.
And they rise and fall. So if we get another tablet, you can make it go again.
Yeah, I'll do a kicking point.
So they're vitamin C tablets.
Can you
Just ordinary vitamin C tablets, I can see that.
break this, please?
So you break them up into
That
small
did
bits and then try and drop them in the middle. Otherwise you get the bubbles all around the sides and then you can't really see into your lava lamp.
Okay, that's a sensible suggestion. There's a lot of bubbles in the red one.
Now it's back into action.
If you look at that bit, you should be able to see inside properly.
That's had a big one fall down.
And if you look at the bottom here, you can see the tablets.
So what are the fizzy? What's causing the fizzing? You put a
Well, water reacts with the vitamin C tablets, making them fizz and dissolve. And then when they're very light, they rise to the top.
Bubbly and pink, hers is all bubbly and blue.
Come back with another experiment for you soon.
That's better.